Hello friends, welcome to my Hariharan Express channel. Today I will discuss another topic, that is the execution of register reference instruction. That means how defined that is execute register reference instruction. First of all, we have to find out what is the register instruction or register reference instruction. How to define, how to know that the instruction is a register reference instruction. We have already discussed a different category of reference instruction. First one is a memory reference, second one is a register reference, and another is a input output reference. So different category of instructions are there. It is defined through certain format by which we can get that is which instruction recognized as register reference instructions. Okay, I will give some instructions, then we can find out how it is defined, the register reference instruction. So actually the register reference instruction is defined through one format, and it is defined on D7. Whenever we define the different kind of a decode of instruction, one part we can get, that is D7. That D7 is actually defined for either memory reference or register reference or input output reference. The D7 role of D7 is very important. If we go through D7 is 0, then it is a memory reference. We have already discussed in last lectures. And if D7 is 1, then it has a 2 reference. One is register reference, another is that is a input output reference. Still, that is I will say you that is if D0 is D7 is 0, that is a memory reference. We can tell as a memory reference. Okay, if it is 1, then it is depend on that I mode or that is a mode. Okay, if it is 1, then again another condition we apply, that is a mode. If I is equal to 0, okay, if I is equal to 0, then we can go through, that is a register reference. Register reference. Very simple way we can define how which reference we can consider. Again, D7 is 1, again I is equal to 1, first I is equal to 0, register reference. If I is equal to 1, then we can go through input output reference. In this way, different memory different reference instructions we can define or design. Okay, this is the basic concept to know how to define memory reference. But whenever we go through some execution or which kind of statements is defined for register reference, what is the process, what is the format to define register reference instruction. I will give some basic instruction, then we can find out how it is designed. Okay, whenever I go through that is a register reference, I told that it is defined through that is a D7 as well as mode. Okay, whenever a mode is 0, then go through register reference. Okay, and in the last class I have already told that is whenever go through some certain flow chart of execution of instruction cycle, flow chart of instruction cycle, that is based on different time slot, the process or phases of instruction need to complete. Okay, like T0 we just assess or that is fetch the instruction, T1 then something, T2 is decoding, next T3 is execution. Like this we have to create a different phases of instruction, and lastly we got the execution. So it also define the time slots at what time it will execute. Similarly, in that case what happens, actually T3 time it will execute, T3 time for execution. Okay, if it T3 time for execution, then what happens, what is the process to design this register reference. From this we can find or we can design for that is a statement for the register reference instruction. Okay, another is if we go through register reference instruction, it actually defined through that is a certain part, that is 0 to 11, all of you know that is address part is defined through 0 to 11, that is 12 data defined through register reference. This is the basic concept, because this is the address part, that address part defined through register reference. Okay, and opcode part defined through memory reference. Like different concepts are there, we also that is considered accordingly. So here is essentially address part defined through register reference. There is 12 statement we have to design, by which register can identify which operation need to operate. Okay, now we will define, that is what is the basic concept regarding on that, or a basic statement for register reference instruction. How to define? Basically, I also told that is it depend on D7, next mode. Again, when I execute of that register reference, then again at what time? T3 time we will consider. Now we will start what is the statement, how to design the statement. Very simple way I will tell you, you also analyze accordingly. Now see, since it depends on D7, then first we write D7. Okay, D7, it depends on D7. Next come to the, that is I is equal to 0. I is equal to 0 for register reference, we have already discussed. Then what happens? If I is equal to 0, then what happens? We just consider I complement. Normally I value will consider 1 as positive. If it is 0, so obviously it will complement. That is I complement. Then at what time? Na T3 time. So T3 time we will consider. Now we just this is the one kind of statement, means register reference statement. Register reference statement need to design. How to register reference will be designed like this. This is the basic concept to design register reference statement. I will show you, then you can understand after that. So initially D7, okay, D1 is complement, I complement, D7 first consider I complement, since it is 0 for register reference, I complement, and T3 time we will define. So let us consider this total is register reference, because we have already considered this is for register reference. Okay, that means we can write it like this, that is common to all. This is the R, it is this register reference is common to all, that is we can write common to all register reference. It is common to all register reference instruction, not particularly all, it is common to all register reference instruction. That means we define R based on that D7, I complement and T3 as a common for all. One statement we have to define. Okay, another part is IR, that is IR is equal to I, that is BI. What is BI? You see IR, this IR means this particular index defined through defined, that is 12 bits. Here you see 12 bits, 0 to 11. Okay, that is this bit actually what happens, bit in how much? 0 to 11, 12 bit it will define. Okay, the instruction register having address part content, that is 0 to 11 bit, that 12 bit that specifies the operation. 12 bits specifies the operation. Okay, so now we very easily we can define the register reference statement very easily, because this part I told that this is 0 to 11 or 12 bits defined for register reference. Okay, so now we see this common register defined through R, and here is BI, that for register reference. Combined to that to make RBI. Okay, combined to them, then we can define the statement. Okay, the statement is defined in this RBI. That means whenever I define register reference statement, we have to bound to write this kind of a statement RBI, where R is register which is defined through D7 I complement T3, and BI bi for b, that is that particular operations. What kind of operation we define? Okay. Now we start these, but through these statement how define different operations. That means a register reference operation, how it is defined. Before definition of define any kind of operation, we need to again repeat this one very simple way. First of all, we consider all instructions or all register reference by R, and this is a different operations through BI. Okay, combination of that R and BI to make a different register reference statements. Okay, now we'll start this different register reference statement through RBI. Okay, now we'll start very simple way. I will that is explain all register reference operations. Okay, now we see different symbols also we can use. What are the symbols? Very simple way. You see CLA. Okay, CLA, or here also very initially actually data we can consider simple R register. Simple register we will consider. Register means that we have already discussed in last. Here you see R means D7 I complemented T3 is equal to R. Means all register just started, not execute, just started. Means sequence counter is 0. If just a statement register statement start, that sequence counter is 0. SC is 0. Means time will activate initially. Then whatever the register data is there, you have to clear all register data through sequence counter. That is clear, it means clear SC, sequence counter. Okay, clear sequence counter. Like this we have to define. Next, now we will start actually that different statement R B11, because we have to define B0 to B11. You see very simple way. It is a B0 to B11 we have defined. Just combine with the RB. Okay, R, that RB0 to RB11. RB1, RB2, RB3, RB2, it's like this. We have to define RB11. From top to bottom or bottom to top we also can consider, no problem. Okay, now we say here you see if RB11, then what happens here? SC accumulator value will be 0. That means a clear accumulator. We can tell how to define this one. No, it is fixed. We just analyze. We can't that is change its data. Okay, we can't change it. It is fixed. We just assume and we have to analyze. RB1, that is clear the accumulator. Okay, so accumulator clear means SC is equal to 0. So clear accumulator. Similarly, CLE, here is clear accumulator, CLE. Okay, CLE. What is CLE? CLE means you know that the enabled will be 0. So RB10, it is defined by the statement RB0. Okay, enable is 0. Okay, enable 0. That means the clear enable, clear E enable is 0. Clear enable, no problem. Okay, next is CMA. Here RB9. Okay, here is CM is actually it's a complement of A. CM means complement. Complement of A means accumulator. A means accumulator. CM means complement. So complement of A. Very simple. If you accumulator design in this way, so it's complement assigned to accumulator. Okay, so we can write it complement. Okay, complement SC. We can write complement SC. Okay, in this way, very simple way we can also consider. Next is a CME. CME. Okay, CME is you see CM is RB8. Okay, RB8. In this case, what happens? E complement transfer to E. Okay, E complement transfer to E. This is that is what we can tell as a complement of E. Very simple, complement of E. Complement of E. if complement of E defined in this way. It is complement accumulator, it is complement of E. Okay, or any data, that is complement point of view you define, here accumulator data, here is normal E data. Next, CIR. Okay, CIR means circulate right. Okay, CIR circulate right means RB7. Okay, if we circulate right, similarly circulate left also there, circulate left also there, RB6. Okay, RB87, B6. In that case, what happens? Right or left? Actually, it is a one circular right or circular left. It is shift operation we can consider. Okay, shift right, shift left. This is the basic concept of that circulate right, circular left means actually we use that is a circular shift. Okay, circular shift. If we go through 7 B7, then what you write? SC. Okay, circular shift SHR SC. Just shift right. Okay, in this case what happens? SC. Okay, which case? SC 15 particular part, SC 15 that bit enabled by E, and SC or E also enabled by 0. Okay, SC also or E enabled by 0 mean SC 0. SC 0 means clear. Enable is fifth. Okay, you see SC clear. SC clear here. SC clear transfer to E. That is here SC clear transfer to fifth. And fifth SC is clear. Then what happens? SC shift right. We go through shift right through this one. So we can write circulated right. Here we can write circulate right. So you can tell why it is take this one, but this is fixed. We can't change it because this is this particular statement is for that. We just analyze. Okay. Similarly, here also same thing. Here right. Here we can write that is left. SH left. SC. Okay. And SC here you see reverse case because it is right, it is left. So if it is 15, so obviously we can go through SC go through 0. Okay, SC go through 0, and that SC go through 0 means here what happens? E transfer to SC 0. Again what happens? Here very simple, E transfer to SC 15 because here is 0, reverse, just reverse of that. Left, right, right, left, just reverse part. Okay, you have already see that that is the most significant bit and least significant bit. Just changes if we go through left to right or right to left or any kind of shift operation. Okay, that kind of things also we consider here. Then what happens? Circulate left. Okay, we go through circulate left. Next is very simple, increment is RB5. Okay, RB5 increment means very simple, SC just increment SC plus 1 increment, no problem. That is we can go through increment SC, just increment point of view we can use this register data will be increment. Actually this is 7 data. Okay, these 7 data is very simple. There is a register reference instruction perform clear point of view. Okay, perform that is clear, complement, circular shift, increment, micro operations, like this we consider these 7 data. Next data other ways we define, like just some condition, some conditional or skip some data. Okay, that is SPA. Okay, SPA. SP means skip. SPA skip, and A for that is accumulator. You see that what is the purpose of skip A or like this. Here RB4. Similarly SPSN. Okay, that is positive negative. Actually the concept is positive negative. Positive for P, negative for A. So RB3. Okay, in this case what happens, SC, right, SC, sorry, if SC, okay, if SC, actually it is 15 position, if SC position 15 is 0, okay, then if SC 15 position 0, then PC increasing, PC transfer to PC plus 1. Okay, in that case what happens, skip if positive, because SPN is positive. How to positive? That is, if SC 15 position 15 bit is 0, 0 means positive. Remember, 0 means positive. Sometimes we will also define through a number is positive or negative. That means 15th position of the data is 0, then it is positive. So PC will increase, that come to next instruction. So skip if positive. Similarly, same case, if, okay, that SC 15 is 1, then what happens? Okay, if it is 1, then PC also increasing, PC plus 1, then what happens? Skip if negative, because what happens, 1 for negative and that particularly 0 for positive, 0 for positive, 1 for negative. Okay, next, this is for that is 3 is over. Next, skip ZA. Okay, skip ZA. ZA means positive, negative. Next, obviously some 0 is there, so RB2. Okay, if what happens, SC is equal to 0, if SC, then no position, if SC is equal to 0, then it is 0, then what happens, similar same thing, then PC is plus 1, then what happens, skip, also here write it, that is skip if SC is equal to 0, if SC is equal to 0, then skip. Okay, this is up to 2. Next, S, okay, ZE, SZE, it is for what, accumulator 0, another is enable, RB1, if same thing is equal to 0, okay, same thing is equal to 0, then PC is equal to PC plus 1 and skip if E is equal to 0 or E0, if E is 0. Okay, this is the one part. Another is similarly very simple, halt. Okay, halt is RB0, RB, this statement will be halt if S0, that is what is S is a start stop flip flop. Okay, that start stop flip flop, that is halt the computer, okay, if HLT identify the symbol or through RB0 statement, then computer will be halt, there is no proceed of any kind of work. Okay, so with this with different register, how different register statement will activate and execute, and how to define that statement, certain format also there, I also explain, we also apply. That we need to remember actually these different operations, but it is designed in this way. So this is the register reference that instruction we define in this way. One part is symbol, another part is statement, another part is operation, another part how to define what kind of name of that operation. In this way, different ways we can define the register reference instruction. But the most important part, whenever you define this statement, that statement means register reference statement is most important. It is defined through in this way. To depend on this R, because we see statement is defined with the R and another is B. R is defined through what? Depend on the D7 value, I mode value and T3 value. Okay. Why it is I dash? Because I is equal 0, that is register reference. Since 0 means I complement. Okay. In this way we define or design that register reference instruction. It is one kind of a concept how to define or how to design register reference instruction. Okay. Thanks to all to watch my videos. Please subscribe my channel, and if you want to give some comments, you can give comments, and like our channel or also videos. Okay. Your helping is required, your suggestion is required to improve my channel and to proceed or progress our channel and improve our different videos. Okay. Thanks to all. Thank you very much to all.